Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, we are told that there is a 10-gram object that's undergoing simple harmonic motion. It has an amplitude of 2 millimeters, a maximum acceleration of 8.0 times 10 to the third meters per second, an unknown phase constant, and we're trying to find out what the period of the motion is, the maximum speed of the particle, the total mechanical energy, what the magnitude of the force on the particle when it's at its maximum displacement, and half of its maximum displacement. So starting off with the period, we're going to start off with the equation A acceleration equals omega squared times displacement. We have the acceleration as 8.0 times 10 to the third. That's going to equal our omega squared, and we have our xm, which we want to convert from millimeters into meters, so 0.002 meters, and that gives us omega. When we solve for omega, we end up getting that omega is 2,000 rads per second. Now that we have omega, since omega equals 2 pi times the frequency, we can now substitute that in, so 2,000 rads per second equals 2 pi times the frequency, and we find out that our frequency ends up equaling 318. Now that's 318 hertz. Now that is useful, but we want the period, not the frequency. So we need to do one more where t, our period, equals 1 divided by our frequency. So 1 divided by 318, and we get that our frequency is 3.1 times 10 to the negative third seconds. That is our total period for this problem. Our next part, now that we have our period, is to figure out what our max velocity is. And I'm going to put up here that we also now know that our omega is 2,000 rads per second, because that's something we just calculated and it's going to be useful to have later on. So if we're going to use this equation, or we're going to work through this equation, velocity equals omega times our displacement. Then we can substitute in our omega, which is 2,000 rads, and we also already have our displacement, so 0.002 meters. So our max velocity is actually going to be 4 meters per second. Next part is working with the total energy at the maximum speed, or the total mechanical energy of our oscillator. Now, since the total energy is going to be kinetic energy, because at max speed potential energy is 0, we're going to work with the equation energy equals 1/2 mass times velocity squared. So our energy is going to equal 1/2 our mass, which we're switching into kilograms from grams, so 0.10 kilograms, times our velocity, which we just found, which is 4 squared, and we get that our total energy equals 0.08 joules. All right, next is finding our our force, our maximum force. So we have F equals ma. So our force is our mass, which is 0.010. We have our acceleration, which is 8 times 10 to the third meters per second. So our force, our max force, ends up being 80 newtons. Alright, and the last part is finding what's going to be the force at half of the maximum displacement. Well, since F equals our spring constant times our displacement, if our displacement is half of our, if we're at half of our maximum displacement, then we're also going to be half of the force. So since our force at maximum displacement is 80, then half of our force is going to be 40 newtons.